Okay, so number 7 says, without a calculator, we're going to find all the solutions for the equations from 0 to 2 pi. So this 0 to 2 pi are all the allowable answers that we're going to give as far as being from 0 all the way to 2 pi radians. Now, the way it's written here, I want you to see that the bracket is on the 0, so it would include 0. And parentheses is on 2 pi, saying that it will not include 2 pi, but everything else is fair game as far as to be an acceptable answer. Alright, so let's go ahead and begin. So our goal is to try to solve and get x all by itself. Okay? So ultimately, yeah, you have other pieces over here that you're going to have to factor and GCF and all kinds of strategies, but the goal is to get x all by itself. Alright, so let's begin. So adding 1 to both sides and then dividing 2, we will get sine of x is equal to a positive 1/2. Okay? So again, my goal is to get x all by itself. So from here, I can draw the unit circle and think to myself, the sine is the y value, and because I'm looking for the y value that is positive, I know that I'm going to be in quadrants 1 and 2. So I need to find from these points that we learned from the unit circle, which one has a y value that is 1/2. So 3, 2, 1, 3, 2, 1, it's going to be here at pi over 6, and another one here at 5 pi over 6. So we're going to say x is pi over 6, and the other one is 5 pi over 6. Again, we want it to be the y value that is positive 1/2. Alright, so let's go to B. B is factored out together already as far as it has a multiplication there, where we can set up pretty much 2 sets of answers by setting each binomial equal to 0. Now solve them independently. So we add 1 to both sides so that we have tangent of x is equal to 1. And now I'm going to envision on the unit circle, when is the y over x a positive 1? Well, in class we did discuss that tangent can be viewed as slope, like m. So if I have 1, I'm thinking of y equals x because the slope of this line is a positive 1. So that's where they're going to occur as far as being positives here at pi over 4. And then 2, 3, so here we go. 2, 3, 4, 5 pi over 4. Alright. And now we're going to go to, and this is where it's a positive 1. So pi over 4 and 5 pi over 4. Now let's go and solve the right side. We have sine of x is equal to a positive 1. And if I were to draw a quick sketch, I know that the positives, y values, because sine is y value, are going to occur up top. And here at pi over 2 is the only location where I'm going to have a positive 1. Okay, so that positive 1 is what I was looking at, and there it is, at pi over 2. Just like over here, that tangent slope of 1 is where I was looking at, pi over 4 and 5 pi over 4. And last but not least, those positive 1/2 I was looking at sine-wise at pi over 6 and 5 pi over 6. Alright, so let's go ahead and box our answers. And there we go. Now we just got to go over to C, D, and then E and F. Same thing. So here, I notice that there are 2 terms because they're separated with addition or subtraction. So the first term is all of this, cosine and sine. The second term is 2 cosine. So from practice that we've had in class, you should identify that you can GCF out a common factor of cosine of x. So what's left, if you divide out a cosine from this first term, is sine. And what's left over here, if you divide a cosine from this one, would be minus 1. And yes, if you were to redistribute, you would get the original problem that was given to you. Okay. So Now that I have multiplication existing between these two pieces, I can go ahead and have two sets of answers. Cosine of x is equal to 0, and sine of x minus 2 is equal to 0. And then we're just going to solve for x like there were two different problems. So, when is the cosine a 0 value? Okay, so that will occur here, 0, 1, at pi over 2. And it'll also occur here, and I'm talking about the unit circle, of course, at 0, negative 1. Which in this range, the way it's being described, is not going to be a negative pi over 2, but instead a 3 pi over 2. That would be that answer for that. Now, let's go ahead and go to this one over here as far as when is the sine of x equal to 2? Well, the highest that the graph ever goes y-wise, whether you're looking at it as like a unit circle, is 1. If you were looking at it like a sine graph, the highest again that it will ever go is 1. And I'm talking about in its default unit circle appearance. So you have 1 and negative 1. So it'll never go to 2. It's too far away. So we're just going to say that for that set of answers, you have no solutions. So no solutions for that set. We have pi over 2 and 3 pi over 2. As far as where the cosine is 0 over here. So you'll have pi over 2 and 3 pi over 2. Looks like they'll be the answers there. Alright, so now let's go to D. D, we're going to do another possible GCF as far as what you see. But first, let's go ahead and see what any of this can simplify to. I'm going to change tangent to sine over cosine. And then I have 2 cosine, which is 2 times cosine. And then there's multiplication. These are over understood ones. And now we're going to subtract sine of x over an understood 1. And then cosecant is 1 over sine. All of this is equal to 0. Through multiplication pieces, cancellation to 1, we know those will cancel and 1 will be left. These will cancel and you will have 2 sine of x left. And now you can set it equal to 0. Okay, so if I now solve for this, I'll have sine of x is equal to, add the 1 over to the right, divide by 2, is 1/2. So from the unit circle, y value is positive whenever it's above the x-axis. And we want it where it's 1/2 as far as the y value. So that's going to occur here and here because we have root 3 over 2, 1/2. And we have negative root 3 over 2, 1/2. Because we're talking about sine, which are y values that are positive 1/2. So our answers for this one will be at pi over 6 and 5 pi over 6. Again, still keeping true and remaining within 0 to 2 pi. Now let's go to E and F and we'll be done. Okay, so we have 2 cosine squared minus 1. So if I add the 1 over, now if I divide by 2, now here comes the step. Very, very important. A lot of people mess up here on this step. If I square root both sides, I need a plus and minus over here where I have this constant all by itself. We don't put the plus and minus in front of the variable side. It's only in front of the constant side. So off to the right, I'm going to write 1 over 2 is the same as if we were to take the square root of the top over the square root of the bottom, and we still have plus and minus. We know the square root of 1 is 1, and then the bottom would be root 2. And if I were to rationalize this by multiplying it by a form of 1, I would get root 2 over 2. So root 2 over 2 is really what this will simplify to. And it's going to be equal to just cosine of x, because the square root will cancel this square out to a form of 1, and now this is what you're looking at. So you have to ask yourself, cosine is an x value, and we want, when is the cosines, basically on the unit circle, when is the x value a positive or a negative root 2 over 2. I'll put the negative in orange so you can see it a little bit better. So this is going to occur, from what we have unit circle memorized, what? It's going to occur at the 45 degrees. Okay? That's when the x value, because it's cosine, will be that positive or negative root 2 over 2. So that's going to be here. Here is another positive root 2 over 2. And then over here you have negative root 2 over 2. And then you have over here negative root 2 over 2 for the x and negative root 2 over 2 for the y. Again, we are looking for cosine, which is x values. So there's the positives. And here in orange are the negatives, just color coordinating them to match up what we put over here. And they will occur at the following answers. So x, this is my theta, my degree, at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So let's go ahead and list them all out. 3 pi, 4, 5 pi over 4, and finally 7 pi over 4. All those are the answers for E. Now let's go to F. F is a little bit involved. We do have, it almost feels like an ax squared term here, a bx, and then a c term over here. So we know from quadratic formula we set it equal to 0 because we have that x squared term and that x term. And in this case, that's talking about the sine squared and the sine. Okay? So let's go ahead and set it equal to 0 like this by moving this to the left, saying sine squared x minus 2 sine of x minus 3 is equal to 0. Now, from algebra 2, with factoring skills, I know that these first two terms are going to multiply to give me sine squared. So that'll be sine of x and sine of x. Furthermore, I know that these last two terms in these binomials will multiply to get me a negative 3. So we can say 3 and 1, or the 3 is going to be negative and the 1 is going to be positive, because a negative times a positive is a negative. And also because a negative 3 sine of x added with a positive 1 sine of x will in fact give me a negative 2 sine of x. So they both worked. Now that I have my two sets of binomials, I can set this first one equal to 0 and this second one equal to 0 and solve them as they were independent problems. Let's go ahead and add 3 to the right. And we know sine can never go up to 3. It's just at 1, as we showed earlier in the other example. The highest it can go is 1, the lowest it can go is negative 1. And that's what we know as far as the fundamental parent functions of sine and cosine. So no solutions for this piece. However, this one does have solutions, or it has one solution. Subtracting the negative 1 over, we know that sine is negative 1 here at 3 pi over 2. So we get 3 pi over 2 for that answer. And that's how you would do 7 in its entirety.